Hi everybody, happy Tuesday. The first thing that we're going to do in our lesson is go through the homework assignment. Now, I'm not actually requiring you to submit the homework, but I am expecting that you are going through the homework assignment, and if you have any questions on any problems, that you are speaking up and asking, whether it be you sending me an email or you commenting directly on one of the posts on Google Classroom. So for number one, we have a linear function because the graph is a line. When we look at, for number two, a table of values, we're looking specifically at the y values. And if there's a pattern of multiplication or division, that's going to be exponential. For number three, for the y's, we don't have a pattern of multiplication or division. If we go from -4 to -1, we have to divide by 4. But if we divide -1 by 4, we get a decimal, -0.25. So that pattern wouldn't hold through this entire row. There is a pattern of addition, but it occurs in the second difference. So in order to find it, we're going to figure out what we have to add or subtract to get from each number to the next. And then there is a pattern between 3 and 5 and 5 and 7. And it's that we have to add 2 each time. Add 2 and then add 2 again. So there is a pattern here in the second differences, which makes this for number 3 quadratic. For number 4, we have a curved graph, that's exponential. And for number 5, we have a parabola shape, that's quadratic. For number 6, we have again a pattern in the second differences, which makes that a quadratic function as well. On the back, we had to do a couple graphs of quadratic functions. So I'll just kind of pause here for a minute so you can take a look at the table of values. So I subbed in all the x values in this column in for x into the function and simplified to get the values of y, and then I created 5 ordered pairs that I plotted on the coordinate plane. In this problem, a is negative. That's what makes the parabola turn upside down. And because a, if you ignore the negative, is a quarter or less than 1, that's what makes this graph become wider. For number 3, same thing. I subbed in the x values in this column. I simplified doing exponents before multiplication to get the y values, and then I generated ordered pairs from the x comma y. I plotted those 5 points on the coordinate plane to make the parabola shape. The a value in number 8 is positive, so that's why the parabola is still facing up. It's going, it's an upright U. And because a is greater than 1, that's what makes this graph look a little bit narrower or closer to the y-axis. So the first one up here looked wider because a was a fraction less than 1. Here, the parabola was a little bit more narrow because a was greater than 1. So the notes that we're going to look at today say notes number 6 at the top, and we're basically just going to do a little bit of a review of exponential versus quadratic functions. What I really want us to be able to do from today is tell the difference between exponential and quadratic functions and look at characteristics that make the graphs go different directions and go different ways. So the first 2 graphs we're going to take a look at here are the first 4 actually we're going to take a look at are exponential. The first 2 graphs up here have a b value that is greater than 1. b is 3, b is 3. When the value of b is greater than 1, the function moves farther away from the x-axis over time. So the x-axis is here in both of these graphs. So notice as we move along the x-axis, the function starts to move away from it. Here, as we move along the x-axis, the function moves away from it. The only difference in these two graphs is that here we have a negative in front, and the negative is not in parentheses. When a is positive, when there's no negative in front of here, when this is a positive value, your function is going to be above the x-axis. Versus when a is negative, or you have a negative out in front, the function is going to be below the x-axis. The next two graphs are also exponential, but these are the cases when b is between 0 and 1. So here b is 1/4. Here b is 1/4, between 0 and 1. These graphs differ from the top two because these graphs are getting closer to the x-axis. So the x-axis is here. So over time, as we move along the x-axis, the function gets closer and closer and closer to it. As we move along the x-axis, the function gets closer and closer and closer to it. So that's the difference. When the base is between 0 and 1, the function actually moves closer to the x-axis versus up here, move farther away. Still, when a is positive, the function remains above the x-axis. When we have a negative out in front, the function then falls below the x-axis. If we flip to the back, we're going to take a look at some quadratic functions. Quadratic functions have a variable base and a number exponent versus the ones on the front, which had a number base here, and the x was in the exponent position. So now we've reversed that. So here is the graph of y equals x squared. And then I have a couple other graphs where I change the value of a out in front. So for this first graph, I've put a 4 out in front. When the number out in front is positive, the u stays upright. When the a is negative, that's when the u is going to face down. When this number out in front, if you ignore the negative, is, or you take the absolute value of it, if this number out in front is greater than 1, so it's 4 in both of these cases, your parabola starts to get really skinny and thin. It starts to get closer on each side to the y-axis. If you look at just x squared, where technically there's a 1 out in front, these two graphs are thinner or narrower because they've squeezed closer to the y-axis. If we look at the two on the bottom here, I've now changed the value out in front to a number between 0 and 1. So a is a fifth. A is a fifth. Again, if a is positive, the u is going to remain upright. If a is negative, the u is going to turn down. If a is between 0 and 1, the function is going to look wider. So it's going to start to move away. The ends of the u are going to start to move farther away from the y-axis. So again, if you look at the difference between x squared up here and these two down below, they've gotten wider than the graph that technically has a 1 in front. So if you see a number in front for a that's between 0 and 1, your graph is going to become wider.